Okay, here we go. I just was experiencing this technical difficulty, but we're ready to go here now. So this section that we are going to be looking at now, we are looking at a section uh, dealing with multi-step inequalities. So by the end of this section, I'm hoping you can say that I can solve multi-step inequalities. Okay, so take some time, read this question, and see if you can think of an inequality that would go with this. Okay, so when I read this problem, it says the math club members are selling pie t-shirts or pie day t-shirts for $7.50 each. The goal is to raise $500 by Friday. The figure at the right shows how much they have raised by Wednesday. What's the minimum number of t-shirts they must sell in order to reach their goal? Explain your reasoning. So when I think through this, I'm thinking this as an inequality. That may be weird, but that's the way I think of it. So I think about how much they have sold. They have sold $337.50 worth. I'm thinking that they got to sell a few more t-shirts, and they're $7.50 each. So my unknown, my X, is equal to the number of t-shirts. So when I say I got $337.50 plus $7.50 X, because that's times however many t-shirts that I have to sell, has to be greater than or equal to $500. That's my goal. So why greater than or equal to? Because I have to raise at least $500. Okay, so how would I go about solving this? Well, I would first subtract off the 337.50 from both sides, and I'd be left with 7.50x is greater than or equal to, well, fancy calculator here. I would get $162.50 that I'd have to sell yet. So if I divide that by how much each of these t-shirts cost, which is $7.50, I would get X is greater than or equal to 21.6 repeating. So how many t-shirts am I going to have to sell? Well, if I sold 21, I wouldn't quite make enough, so I have to sell, the X has to be greater than or equal to 22 t-shirts. Okay. Okay, so this is the type of thing we're going to see today. Some of them that just might be problems where we don't have to write the inequality, where we just have to solve them. So let's take a walk through these three examples, and hopefully by the end of these three examples, we're feeling pretty comfortable with this idea. So the first one, it says, what are the solutions of the inequality? Check your solutions. So we basically have to solve the inequality. So I would start out by adding a 7 to both sides, and I would get a negative 6 is less than or equal to, negative 6a, sorry. Negative 6a is less than or equal to a 24. Next step I'd have to divide by a negative 6. So I now have a, I have a negative 4 over here. But since I divided by a negative, I have to remember that that means I have to switch that inequality. So I'd have a is greater than or equal to a negative 4. So what does it mean to check your solutions? Well, you could check a number that's greater than negative 4. So for instance, 0. 0 is greater than negative 4. So I can plug that back into my original. Negative 6 times the 0 minus 7. We want to know, is that less than or equal to 17? Well, negative 6 times 0 is 0. 0 minus 7 is a negative 7. Negative 7 is definitely less than or equal to 17. So my answers do make sense. Okay, next problem. I would first subtract 5 from both sides, and I would get a negative 9 is less than a negative 3n. My next step, I would divide by the negative 3, and I get a 3 is less than an n. Did I do that correct? Your answer should have been no. because I did not switch the inequality symbol. So I divided by negative, so I have to remember to switch that inequality symbol, and I'd have negative, or excuse me, positive 3 is greater than n. So tell me, a number that would work? Well, I could think of a number like 2, because 3 is greater than 2. So if I check 2 back in my original, we want to know, is this a true statement? Well, 3 times 2 is 6. 5 minus 6 is a negative 1. Is negative 4 less than a negative 1? And your answer should be yes, it is. So once again, I did get the right answer. Okay, my next problem, letter C here. I would first subtract a 30 from both sides. And I'd have a 20 is greater than a 0.8x. So if I wanted to solve that, I would now divide by a 0.8 on both sides. And 20 divided by 0.8 is a 25. So 25 didn't divide by a negative, so I don't need to switch the inequality. So 25 is greater than an x. So 25 is greater than what numbers? Well, I could think of a number like 20. So 20 is less than 25. So 20 is my number I'm going to check. So we're going to check this. 50, is that greater than a 0.8 times 20 plus 30? Well, 0.8 times 20 is 16. 16 plus 30 is 46. 50 is greater than 46, so yes, I have done that one correctly as well. Okay, another problem you might see would be something like this. In a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. You have at most 42 feet of fence. What are the possible lengths of your garden? So for this, I'm thinking of the formula. Perimeter is equal to twice the length plus twice the width. That's what's kind of going through my head. So my perimeter, what's the maximum it could be? The maximum it could be is 42. That's how much fencing I have. So this has to be greater than or equal to whatever I have here. So this is a length. This is a length. I don't know either one of those. I know that this side right here is 12. I know that this side must be 12. So my widths are 12. So it would be like this. 2 times the lengths, which we don't know, plus 2 times the 12. 2 times 12 is 24. So I'd have 42. It's greater than or equal to 2L plus 24. So to solve this, I could subtract 24, and I'd have an 18 is greater than or equal to 2L. If you divide by the 2, you'd have L is less than or equal to a 9. So how long can my lengths be? Has to be at most 9 feet long. Okay. Next step. Okay, what are the solutions of this one? So I might have an inequality that looks like this. So I got, just to rewrite it to work with it a little bit here. So hopefully when you see the parentheses, the first thing that's going through your head is I'm going to distribute. So after I distribute, I'd have a negative 8a is greater than or equal to 10 minus 8a. So now, if I add 8a to get the a's all together, I would get 0 is greater than or equal to 10. So similar to last chapter, we were looking at infinitely many, or the identity, no solution. If I have 0 is greater than 10, this is a false statement. So I'd have to say that there is no solution. There's no number that I can put in for A that's going to give us a valid answer. Okay, same idea here. Let's take a look at this one. So that's done. I've got a negative 5. It's greater than 7m plus 7 minus m. So if you take a look here, we got like terms on this side So if I combine them, I'd have a negative 5 is greater than 6m plus 7. So my next step, I could subtract off that 7, and I'd have a negative 12 is greater than 6m. I could divide by the 6, and I'd have a negative 2 is greater than m. Or if you want to switch it around, it would be m is less than a negative 2. Okay, very good. I'll give you some time. You try and figure this one out right now on your own. Okay, so I have 18. X minus 5 is less than or equal to 3, parentheses 6x minus a2. So, first thing you should be thinking is to distribute on the right-hand side. So, I have 18x minus 6. So, I have 18x minus 5 is less than or equal to 18x minus 6. So, if I get the x's together on the same side, I would minus the 18x. And once again, the x's cancel out on this one. So I get a negative 5 less than or equal to a negative 6. So we have to ask ourselves, is negative 5 less than or equal to negative 6? And hopefully we are saying that no, that is not a true statement. So we would say that there is no solution. Okay. Now, if it came out to the situation where it was negative 5 is greater than or equal to a negative 6, now this is a true statement, so this one would be an example of all real numbers. Any number that you put in there is going to work. Okay, very good. Take a look at this one, see if you can figure out what you do on this one. So when we read through this one, hopefully we're thinking of a problem similar to the rectangular garden problem that we just got finished working through. And we should be thinking, okay, I've got a garden, or a perimeter of a rectangle, excuse me. We know that that's at most 24. So we got perimeter is equal to 2L plus 2W. So I know that I've got 24, and it's at most 24. So I cannot go over 24. So this stuff over here has to be less than it, okay? So the opposite sides, they're both 4 centimeters long. So 4 centimeters, 4 centimeters. We want to find out what these two sides are. So once again, it would be 2L plus 2 times the 4. So when I do that, I'd have 24 is greater than or equal to 2L plus an 8. If you continue solving, you'd minus the 8, and you get 16 is greater than or equal to 2 times L. If you divide by the 2, you'd have an 8 is greater than or equal to an L. Or the length has to be less than or equal to 8. And in this case, 8 what? 8 centimeters. Make sure you're getting those label on it if you got a word problem. Okay, that I believe is it. So that's a wrap.